what is our class procedure, right? So class procedure means, so here today I will start the first unit, atomic structure unit, right? So there are 14 units in the chemistry syllabus, A-level chemistry syllabus. So today I will start the first unit, right? And here the procedure is, so I will completely teach you the theory part, right? Then I will provide you tute, right, containing model questions and past paper question, right? So then after each theory part, right, after each theory part, I will discuss the questions, right? So here for the first unit, this kind of tute will be provided. This kind of tute will be provided. So then you can see this contain model questions and all the past paper question. And here this is divided to parts, topic to topic, right? Each tutes divided to topic. That means first I will complete the first topic of the first unit. Then after that, I will discuss this model question. That means these are the exam targeted question, right? Exam targeted question. So then here there are past paper question regarding this topic, right? Regarding this topic. Then like this, I will do some theory part. Then I will discuss model question and past paper question. This is the first unit tute. Before the next class, I will send this tute to your home, right? So similarly for the other units, so this is similarly this tute is given to the unit number 5, right? Similar way. And here this is organic chemistry tute, unit number 11, and unit number 4, right? And unit number 3, right? So similarly, each of the tute contain model question and all the past paper question, and all the model question, all the past paper questions are discussed, right? And during the class, first I will teach. Then when I teach, don't write down the note, right? After completing the theory part, I will give you the time to write down the note, right? And next, I will tell you what is my qualification, right? So I am a graduate of University of Peradeniya, chemistry special, right? So then about 4 years, I studied the chemistry in university, right? So the knowledge of that degree, I will use to explain the theory of the A-level syllabus, right? That means I learn the more theories than A-level syllabus. Therefore, most of the A-level stuff I can teach by using that knowledge, right? So then first I will tell you what are the 14 units of the chemistry, right? There are 14 units. Just I will give you the name of those units, right? Then today I will start the atomic structure, and then second unit likewise I will complete all the 14 units. And here the special thing is in the chemistry syllabus, all the units are combined together, right? That means to study the second unit, you should have knowledge about the first unit. And to study the third unit, you should have knowledge about the first and second unit, right? To study the fourth unit, you should have knowledge about the first 3 units. Likewise, it's a chain syllabus, right? Therefore, if you miss some theory of some unit, then what happens? You will miss all the theory of the other units. That means if you unit the unit number 2, the structure and bonding part, then what happened? It is difficult to study the mainly the section of organic chemistry section, right? There are 4 units in the organic chemistry section, right? So it is difficult to study the organic chemistry section, right? So like that way, I will explain what is the relationship between each unit, right? Therefore, here I will write down the 14 minutes, right? So here I will write down the 14 minutes of the A-level syllabus. So here chemistry A-level syllabus. So there are 14 units. Right. What is the first unit? It is the atomic structure. Atomic structure. And second unit, structure and bonding. Structure and bonding. Structure and bonding. Then third unit, chemical calculations. Then fourth unit, gaseous state of matter. Gaseous state of matter. Then fifth one, energetics. Then sixth one, chemistry of SP and D block elements, right? D block elements. And seventh one, basic concept of organic chemistry. Basic concept of organic chemistry. And eighth one, hydrocarbons and halohydrocarbon. Ninth one, oxygen containing organic compounds. Then 10th one, nitrogen containing organic compounds. 11th one, chemical kinetics. 12, equilibrium. Then 13, electrochemistry. 14, industrial chemistry and environmental pollution. Right, these are the 14 units, right? And another thing, these 14 units, we can divide it to main 4 parts, right? Main 4 parts. That means as general chemistry, organic chemistry, physical chemistry, and inorganic chemistry, right? So here I will write down the 4 sections. What are the 4 sections? There are 4 sections in chemistry. First one, general chemistry. General chemistry. Second one, inorganic chemistry. Third one, organic chemistry. Then last one, physical chemistry. Right. So what are the units of general chemistry? So units of general chemistry are 1, 2, and 3. And inorganic chemistry mainly 6 and last unit 14. And organic chemistry 7, 8, 9, 10. And physical chemistry 4, 5, 4, 5, 11, 12, 13. Right, 13. So the biggest part in the A-level syllabus is a physical chemistry part. Right. So those are the 4 sections in chemistry. Right. So here, what is it? There is a relationship. To study this one, we need this one. To study this one, we need these 2. To study this one, we need these 3. Right. Likewise, then to study 6 unit, the knowledge of the 3rd unit is required. Likewise, there are a lot of relationship in the A-level chemistry. If you miss the 1st unit, then what happens? It is difficult to study the 2nd unit. If you miss the 2nd unit, difficult to study the 3rd unit. Then like a 7th unit, 8th unit, 9th unit, all are missed, will be missed. Right. So therefore, the chemistry syllabus is a chain syllabus. So therefore, from the beginning, you have to study carefully, right? Otherwise, all the other units will be difficult to study, right? So these are the 4 units, 14 units, and these are the 4 main sections. And in the exam, you have to write down the answer for 2 papers, right? Paper 1 and paper 2. I will get some idea. The structure of the exam. The structure of the exam. Right. So there are part 1. It is MCQ. It contains 15 MCQ. So for this 15 MCQ, mark 50 marks. Right. And part 2, there are 3 sections. Part 2, there are 3 sections. First section, part A, part 2 contain A. It is a structured essay. Structured essay. There are 4 structured essay. And part B, it contains essay. There are 3 essay, but you have to write down only 2 essay. And part C, again essay. There are 3 essay, but you have to write down only 2. Then this 4 structured for structured 20 marks, this 2 structured 50 mark, this 2 structured 50 mark, altogether 100 marks. Altogether 100 marks, right? And the result are given like A, B, C, S, and F, right? So generally, if your mark is more than 75, it is A pass. In between 65 to 75 B mark, in between to 55, 65 C mark, in between about like 35, 55 S mark, above, below 35, so fail, right? And so what is our target? To get A pass. Our final target to get best A pass, right? So to get best A pass, to get good A pass, you have to study from the beginning, right? Then that means from the beginning, you have to study very carefully. That means from week to week, you have to study, right? So the A level is not same as O level. It's a totally different, right? That is a main mistake student will be done, right? The main mistake is they think the A level is similar as O level. It is totally different, right? A level is bit hard than O level, right? And to get good result, you have to study from the beginning, and week to week you have to study, right? That means the theory of today you have to study within this week, and theory of next day you have to study within next week, right? Likewise, you have to continue, right? Otherwise, what happened? You miss the theories, and when we move to the second unit, it is difficult to understand, right? There are a lot of things. We have to do a lot of questions. We have to do understand lot of theory parts. There are very big, right? Very big content in this 14 minutes, right? You can understand to study the atomic structure, right? About 1.5 month. That means about 6 days or about 8 days. We have to use, right? So like that, say these are the big units, right? When consider, I think in the 11th grade 11, the science book like very small book, right? The unit is very small unit, right? So the 1 unit of this A level, the 1 unit of the A level is same as your grade 11 science book, right? Like this, there are a lot of things we have to study. Therefore, week twice you have to go through the notes and do exercises, do the questions, right? Then you can get the A pass. If you miss from the beginning, then it is difficult to understand the other things. Then what happen? You will give up, right? So therefore, from the beginning, you have to study to get the good result, right? And this is online class, right? Therefore, the most important thing is a self discipline, right? Self discipline means don't think I will watch the recordings without participating in the live class. Don't do that, right? So always you have to try to participate live class, right? But unfortunately, since it is some thing, it is difficult to participate the live class, then you can, I will give you the recordings, but try your best to participate the live class, right? And during the class, you have to pay attention to the class, right? And when I teach, the attention is more important thing, right? You have to listen carefully, then try to understand. If you have some difficult point and some doubt, you can send a message to the Zoom chat or WhatsApp to this my number, right? And after the class, if you have some doubt, you can ask, right? I will clarify, right? Then previously I told you, when I teach, don't write the notes. I will give you the time to write down the proper note, right? And I will not provide the printed note because it is important, very important to write down the notes, right? Important to write down notes. So before the next class, I will send you the tute, right? Then today I will start the first unit. We'll discuss the theory part, right? from the next day, I will start to discuss the tune. Right. So now you have to write down this part. First, write down the chemistry level syllabus, then write down these 14 minutes. Right. After that, write down this the 4 sections and the structure of the exam. Right. First, write down these 14 minutes. If you finish the writing, please say the raise hand. Right. So then I will start the first unit, atomic structure. Write down unit 1, atomic structure. Atomic structure. Atomic structure. Right. So in this unit, I will discuss the first part of this unit, is the history part, right? So after that, we discuss there are quantum numbers, electron configuration, variation pattern. Likewise, there are a lot of topics in this atomic structure theory part. So mainly here we discuss the properties of atoms, right? Properties of atoms. And from the beginning, we discuss the history part, right? Right. First thing, matter, right? First thing, matter, right? So the definition of matter is, what is matter? It is anything that has mass and occupy in space. What is matter? Has a mass and occupy in space, right? That means anything having mass and occupy in space, we can known as a matter, right? It is a definition of matter, right? So that means all the thing we can see is a matter. This pen is matter, right? And table, chair, all the things are matter because they have mass and occupy in space, right? And some matters like air, right? So they are, we cannot see and we cannot see and we cannot contact it, right? So therefore, some, when consider some matter, we can see and we can contact, but when consider some matter, we cannot see and we cannot contact, right? So therefore, all the things we can see and some matters it is difficult to see, so they are generally known as a matter. It is the definition of matter, right? Okay, write down first one. Write down as a subtopic like a matter. Write down matter. Then write down under that. Matter is the physical material of the universe. Matter is a physical material of the universe. Physical material of the universe. It is anything that has mass, that has mass and occupy in space. Mass and occupy in space, right? So then when matter are considered, they have different properties, right? That means think like water, we can dissolve something it, and like air, we can breathe, right? So like that way, when consider matter, they have different properties, right? Although the matter has different properties, all of this matter are made of from about 100 elements, right? That means when consider water, it produced by hydrogen and oxygen, right? When consider like glucose, it produced by carbon, hydrogen, and oxygen. right? Like that way, all the matters are made of about 1000 elements, right? So far, about 118 elements are discovered, about 118 elements are discovered, but about 18 elements, they have very short life. Short life means they are radioactive. They are radioactive. That means they emit radiation. So there are elements known as radioactive elements, right? So what are the radioactive elements? They emit radiation, then converts to another element. They emit radiation, then converts to another element, right? So therefore, these radioactive elements are not present in general matter, right? When consider this common matter, these radioactive elements are not present. That is why about 100 elements are participated to produce the day-to-day life matter, right? Okay, write down next sentence, right? Write down next sentence. All the material in our world, all the materials in our world, all the materials in our world, vary greatly, in their properties, although the material in our world vary greatly in their properties, but all of these materials, but all of these materials are made of about, all of these materials are made up about 1000 elements, made up about 1000 elements, about 1000 elements, made up about 1000 elements. 118 elements have been discovered. 118 elements have been discovered so far. 118 elements have been discovered so far. But few elements are short-lived. Few elements are short-lived and not found naturally. Not found naturally. Not found naturally. Not found naturally. Have been discovered so far, but few elements are short-lived and not found naturally. Short-lived means they emit radiation, then converts to another element. Therefore, their lifetime is very short, right? And then what is the chemistry? So the chemistry is the study of properties and behavior of matter. It's a simple definition of chemistry. Study of properties and behavior of matter. That means when consider water, it is present as liquid at room temperature and pressure. Why? What is the reason? Right? It is a chemistry. And when consider oxygen, right? It is a gas. It is a gas. Right? Why? Oxygen exists as a gas at room temperature and pressure. Right? So like this way, the chemistry is a study of properties and behavior of the matter. It is a simple definition of chemistry. Right? Then write down next sentence. The chemistry is the chemistry is the chemistry is the chemistry is the study of study of properties and behavior of matter. Chemistry is the study of properties and behavior of matter. Properties and behavior of matter. I then think there is a question, what is chemistry? Then you can write down, chemistry is the study of properties and behavior of matter. Right. Next one is the atomic theory. Right. The atomic theory of matter. The atomic theory of matter. The atomic theory of matter. Write down next topic, the atomic theory of matter. Right. So this is a history part, the atomic theory of matter. The history part. Right. First thing, Empedocles. Right. So the scientist Empedocles. So this Empedocles believed that all the material, right, all the matter, otherwise all the materials made up of 4 elements, right, made up of 4 elements. What are they? Earth, fire, air, and water, right? You understand? So the first thing, there are a lot of atomic theories. The first one, the Empedocles is the name of the scientist. Empedocles believed that 4 elements, or all the materials are made up of 4 elements. What are those 4 elements? Earth, fire, air, and water, right? That means the Empedocles believe that when consider tree or when consider human, right? They are made by mixing earth, fire, air, and water, like that way, in some ratio, right? It is the first thing. Then next one, next scientist, Democritus, right? Democritus. So this Democritus believe that all the material are made by tiny, invisible, indivisible. Right? Tiny means very small, invisible, we cannot see, indivisible, it cannot be further divided, particles, right? Particles, and Democritus, it is known as atomos, right? Atomos. It is a Greek name. The meaning of this name is this one: indivisible or uncuttable. Indivisible or uncuttable, right? It is the second one. This is the first one, Empedocles. Then Democritus stated that all the material are made by tiny, invisible, indivisible particles and they called as atomos. It is a Greek word. The meaning of this atomos is indivisible or uncuttable. That means it cannot further divided, right? Next one, the Pluto and Aristotle. Plato and Aristotle stated that there cannot be this kind of particle, right? That means they believe that the particle, that means all the particles can be divided, right? Then they stated that this atomos concept is wrong, right? Atomos concept is wrong. Therefore, what happened? The study about this atomos is stopped for few years, right? You understand? The atomos concept introduced by Democritus, but after that, this Plato and Aristotle stated that this concept of this Democritus, the uncuttable, indivisible, it cannot be happen. That means all the particle can be further divided. Then what happened? The scientists believe this concept, and the study about the atomos was stopped. Atomos was stopped for many years, right? So those are the first three. So then after that, I will tell you the other part. First, you have to write down this one. Okay, write down the atomic theory of matter is the topic. Then under that, write down Empedocles. Empedocles believed that all the materials are made by Empedocles believed that all the materials are made by four elements, made by four elements. They are earth, fire, air, and water. They are earth, fire, air, and water. Air and water. Air and water. Next, write down next sentence. Next sentence. Next sentence. Democritus and other scientists. Democritus and other scientists. Democritus and other scientists. Democritus and other scientists described. Democritus and other scientists described the material world has been made of 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 tiny invisible indivisible particles tiny invisible indivisible particles that they called as atomars, that they call as atomars, that they call as atomars, atomos, atomars. The meaning of atomars is, the meaning of atomars is indivisible or indivisible or uncuttable, indivisible or uncuttable. The meaning of atomars is indivisible or uncuttable. That means it cannot be further divided, right? All the materials are made up of particles. It is known as atomars. It cannot further divided. That is the meaning of the atomars. Indivisible or uncuttable particles in the material. All the things are made by that particles, right? That is the idea of Democritus. Next, later, Plato and Aristotle. Later, Plato and Aristotle stated that Aristotle stated that there cannot be ultimately indivisible particles. There cannot be ultimately indivisible particles, and there cannot be ultimately indivisible particles, and the atomic wave of matter, faded, faded for many centuries. Faded for many centuries. Faded for many centuries. That means scientists stop to try to find out this atomars particles due to the idea of Plato and Aristotle, right? Right. Next one, Dalton atomic theory. Next theory, Dalton atomic theory. Dalton atomic theory. Right. Dalton atomic theory. Right. So this Dalton, it's a scientist and a school teacher, right? So this Dalton introduced some atomic model. It is known as a Dalton atomic theory. Dalton atomic theory contains the four assumptions, mainly four assumptions, right? So you have to remember that four assumptions, right? What is the first one? Dalton stated that all the elements, what are the elements? I think you know the elements: oxygen, nitrogen, carbon, fluorine, chlorine, likewise, right? So all of these elements are are made extremely small, indivisible particles called extremely small indivisible particle, extremely small, indivisible. Extremely small, indivisible particles that they call as atoms, right? The same as the Democritus theory, right? The first one, all the elements are made out of extremely small, indivisible particle called atoms, right? So Democritus stated the atom mass, now these atoms, right? Right. But this concept is wrong, right? Then later scientists found that this assumption of the Dalton, this first assumption is wrong. Why? Because the atom we can divide further, right? Atom can be divided to electrons, protons mainly, and neutrons, right? Therefore, later scientists found that the first assumption of Dalton is invalid. It is wrong, right? Atoms can be further divided to electrons, proton, and neutron, right? Then second one, consider the atoms of certain element, right? Consider the atom of certain element, like now consider like a hydrogen, right? So this is the atoms of hydrogen. Think these are the atoms of hydrogen. Then consider like oxygen, the atoms of oxygen like this, right? So then Dalton stated that all the atoms of one element are identical. All the atoms of one element are identical. That means these four atoms of the oxygen are identical. No any different. All four atoms are identical. And all these three atoms of oxygen are identical, right? All the atoms of certain element are identical, but atoms of two different elements are different. That means this atom and this atom are different, right? So then later, right? Later scientists found that there are different atoms in same element, right? There are different atoms in same element. It is known as isotope. It is another topic of this unit, isotopes, right? Isotopes, right? What are the isotopes? Simply we can understand isotopes, different elements of same element, different atoms of same element. Do you understand, right? What is the assumption? All the atoms of same element are identical and atoms of two different elements are different. It is correct. Second part is correct. Atoms of two different elements are different, right? But the first part, when consider some elements, they have different atoms, not identical, right? Then what happened? This second assumption, one part is correct, but other part is false. Atoms of all the atoms of same element are identical. It is wrong because in some elements there are different type of atoms known as isotopes. So third assumption, second one, sorry. Then third one, atoms of one element cannot be changed into atoms of another element. That means think one element, some element, they say this element cannot be converted to another element. Do you understand? Atoms of one element, right? Atoms of one element cannot be converted to atoms of another element, right? Atoms of one element cannot be converted to atoms of another element. This process is wrong according to the Dalton theory, right? But after few years, scientists found that atoms of one element are converted to another atom, converted to atoms of another element by emitting radiation, right? There's another topic as a radioactivity, right? What is a radioactivity? We have to study in detail isotopes, this radioactivity. Here I will just mention radioactivity means some elements emit radiation, then they converted to the another element, right? So after discovering this radioactivity concept, scientists concluded that this third assumption is incorrect. Third assumption is incorrect, right? And fourth one, compounds are produced. Compounds are produced by combining two or more atoms of different element in simple numerical ratio. It is okay, right? That means consider H2O, Fa2O3. So H2O are formed by hydrogen to oxygen 2 to 1 ratio. This is formed by Fa to oxygen 2 to 3 ratio. Like this way, compounds are formed by combining atoms of two different elements in simple numerical ratio. Simple numerical ratio, right? So those are the four assumptions of Dalton, right? Four assumptions of Dalton, right? All of these assumptions are made by John Dalton by considering, right? By considering the atom as a golf ball, right? That means the Dalton think the atoms, right? The atoms like is an imaginary situation. He think the atoms, the particle, the smallest indivisible, uncuttable particles, it is like a golf ball, right? So they think when consider the atoms of hydrogen, right? They are like a golf ball, and all of this golf ball are identical, right? And oxygen like this, right? And this H2O is produced by combining the two atoms of hydrogen with one atom of oxygen, like this kind of model, right? He thinks just like a ball. Simply, according to the Dalton theory, he think the atom like a ball, right? It is known as a golf ball. Simply, it's like a ball, right? So therefore, this model, right, Dalton atomic model, we known as a golf ball model, right? That means according to the Dalton concept, right, the atom is similar as a golf ball, right? All these four assumptions are made by Joel Dalton by considering atom like a ball. It's a simple concept, right? So therefore, the Dalton atomic model we known as a golf ball model, right? So you have to remember these four assumptions of Dalton, right? Now we can write down the note. So write down the topic Dalton atomic theory. Dalton atomic theory. Write down. Write down. Uh, John John Dalton. John Dalton is a John Dalton is a scientist. John Dalton is a scientist and school teacher. John Dalton is a scientist and a school teacher. School teacher. School teacher. School teacher. he introduced his atomic model. He introduced his atomic model he introduced his atomic model by considering four assumptions, by introducing four assumptions. His atomic model by introducing four assumptions. He introduced his atomic model by introducing four assumptions. Four assumptions. Right. Write down first assumption. Write down first assumption. Elements are made out of elements are made out of elements are made out of extremely small indivisible particles called atoms. Elements are made out of extremely small indivisible particles called atoms. Indivisible particles called atoms. Extremely small indivisible particles called atoms. Called atoms. Then write down under that assumption, under that write down, you can use a different color. Later, scientists discovered that the atom can be divided. Later scientists discovered that the atom can be divided. The atom can be divided. The atom can be divided to electrons, protons, and neutrons. Can be divided to electrons, protons, and neutrons. Electrons, protons, and neutrons. Electrons, protons, and neutrons. Therefore, this assumption is invalid. Therefore, this assumption is invalid. 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 Right. Then second one, write down second assumption. All atoms of a given element, all atoms of a given elements, all atoms of a given elements, are identical in mass and size, are identical in mass and size. All atoms of a given element are identical in mass and size, but the atoms of one element, are different. Atoms of one element are different are different from the atoms of all other elements. From the atoms of all other elements. But the atoms of one element are different from the atoms of all other elements. From the atoms of all other elements. Then write down under the second assumption using different color. Later, scientists found that there are different atoms of same element. Later, scientists found that there are different atoms of same element known as isotopes. Found that there are different atoms of same element known as isotopes. Therefore, this assumption is invalid. Therefore, this assumption is invalid. Therefore, this assumption is invalid. Right. Then write down third assumption. Atoms of one element cannot be changed. Atoms of one element cannot be changed into atoms of a different element. Atoms of one element cannot be changed into atoms of different element. By chemical reactions. Full stop. By chemical reaction, full stop. Then atoms are neither created nor destroy in chemical reaction. Neither created nor destroy in chemical reaction. Neither created nor destroy in chemical reaction. Then write down under that assumption, later, scientists found that some unstable elements are converted to stable element by emitting radiation. Stable element by emitting radiation. Therefore, this assumption is invalid. Therefore, this assumption is invalid. Next, this assumption is invalid. Next, Fourth one. Fourth one. Fourth assumption. Compounds are formed by compounds are formed by compounds are formed by union of compounds are formed by union of two or more atoms, union of two or more atoms of different elements. Compounds are formed by union of two or more atoms of different elements in a simple numerical ratio. More atoms of different elements in a simple numerical ratio. Compounds are formed by union of two or more atoms of different elements in simple numerical ratio. Simple numerical ratio. Simple numerical ratio. Right. Then write down after that, all of the above assumptions are made by all of the above assumptions are made by considering the atom made by the considering atom made by the considering of atom as a golf ball, as a golf ball, as a golf ball. Therefore, as a golf ball, therefore, the Dalton atomic theory, therefore, the Dalton atomic theory is known as, the Dalton atomic theory is known as golf ball model, is known as golf ball model, golf ball model is known as golf ball model, right? That means simply John Dalton introduced the atom like a golf ball. It's a simple thing. Right. So what is the next one? Next one, we have to study about the discovery of electrons, protons, and neutrons. What are the experiments used to discover the electrons? What is the experiment used to discover the proton and neutron? Right. It is our next part. Write down first part, discovery of electrons. Discovery of electrons. Discovery of electrons. Discovery of electrons. Right. So early scientists found the electricity, right? That means from the wire, metal, electricity can be conducted, right? Then they try to study how this electricity conduct, how this current is conducted by a metal and some other materials, right? So the scientist Johnston, you have to memorize this name, Johnston G. Stoney. This Johnston G. Stoney stated that the fundamental particle the fundamental particle carrying the electricity is electrons, right? That means Johnston G. Stone stated that the current is flow by using electrons. It is just a like a, that means just he think the current is traveled by electrons simply, right? But he does not prove the occurrence of this electron experimentally. This is just a statement, right? Current is carried by electrons, right? But in the science, some factor is find out, we have to prove it. We have to prove by using some experiment, right? So, but experimentally, the Johnston G. Stoney does not experimentally prove the occurrence of these electrons, right? Then after that, this is just a statement that means therefore we known as the name of this electron. The name electrons, right? This name is given by Johnston G. Stone, electron's name, right? But later, the different scientists experimentally prove the occurrence of electrons, right? And after that, I will discuss that part, right? First, write down this one. Johnston G. Stoney, Johnston J. Stoney, Johnston J. Stoney named, Johnston J. Stoney named the fundamental unit, Johnston J. Stoney named the fundamental unit, Johnston J. Stoney named the fundamental unit carrying electricity, fundamental unit carrying electricity as electrons, as electrons, as electrons, as electrons, but did not have, any experimental evidence, of its existence, but did not have any experimental evidence of its existence, of its existence. Did not have any experimental evidence of its existence, right? Then later, the scientists try to study, right? Scientists study the experiment by using this electrical discharge tube. This is a glass tube, right? In this glass tube, two metal rods, metal plates are placed, right? Then these two metal plate are connected to high voltage. There's a high voltage. Here, this is a negative terminal and this is a positive terminal. This is a high voltage source. Right? So this one, this tube is known as a discharge tube. discharge tube, right? So the metal plate connected to the negative terminal of the high voltage is a metal plate. It is connected to the negative terminal. It is known as cathode, right? And the metal plate connected to the positive terminal of the voltage known as anode, right? So anode is positively charged, the cathode is negatively charged, right? So then there is a vacuum pump. This is vacuum pump, right? By using this vacuum pump, we can control the pressure inside this discharge tube, right? Using this vacuum pump, we can control the pressure inside this discharge tube, right? So then, when using this vacuum pump, the pressure inside this glass tube should be decreases to low voltage, sorry, low pressure, right? Then what they observe that a radiation is emitted from cathode to anode. Radiation is emitted from cathode to anode. This radiation is emitted from cathode. Therefore, this is known as cathode rays. Cathode rays, right? So in this experimental setup, he observed the formation of some radiation. It is known as a cathode rays, right? So this cathode rays was discovered, right? This cathode ray was discovered by William Crookes, right? That initially this setup was constructed by William Crookes, and he found that radiation is formed in this setup. That radiation is known as a cathode rays. After that, scientists try to study about these cathode rays, how they are produced, what are the properties, what is the process of formation of these cathode rays, and what are the particle consist of these cathode rays, right? So those things are discovered by those things. The scientists try to study about these cathode rays after discovering this cathode rays by William Crookes, right? Therefore, the thing there is a question, cathode rays are discovered by, but the answer is William Crookes is the answer, right? Okay, William Crookes is the answer. Then I will continue this part. Okay, and here there is another one. When consider this cathode ray, they don't have any specific color, but when they are hit on some, like here is a discharge tube is contained in the glass tube, right? When this cathode radiation hit onto the glass tube, we can observe some color, right? And inside this discharge tube, there is very small air space. When this cathode radiation hit onto this air, we can observe some color, right? Okay, write down. Scientists began to study began to study scientists began to study electric discharge began to study electric discharge through a glass tube began to study electrical discharge through a glass tube. Through a glass tube containing very small amount of air. Containing very small amount of air. Containing very small amount of air. This device was introduced by William Crookes. This device was introduced by William Crookes. And it is called Crookes tube. It is called Crookes tube or Crookes tube slash discharge tube. Or cathode ray tube. Crookes tube, discharge tube, or cathode ray tube. Cathode ray tube. Right. Draw this structure. Draw this diagram. Fundamental units. The fundamental units means the smallest unit. Simply the now electricity carried by fundamental units, you can think like a small unit. The smallest unit carrying electricity known as electrons, right? That means the current is flowing of current is equal to the flowing of electron flow. Simply draw this diagram. If you finish, raise hand. Right. After this setup, write down the note. The experiment of Crookes. The experiment of Crookes showed that the experiment of Crookes showed that when two electrodes are connected to when two electrodes are connected to a high voltage source, when two electrodes are connected to a high voltage source are connected to a high voltage source, the heated negatively charged metal plate heated negatively charged metal plate called the cathode, heated negatively charged metal plate called the cathode produce a stream of produce a stream of invisible radiation, stream of invisible radiation, invisible radiation. Invisible radiation. Although the rays could not be seen, although the rays could not be seen, although the rays could not be seen, their presence was detected, their presence was detected, their presence was detected because they cause was detected because they cause gases at low pressure to glow, detected because they cause gases at low pressure to glow, gases at low pressure to glow, and gases at low pressure to glow, and which made other substances to give off light, which made other substances to give off light. That means when cathode ray hit into the substance, we can see like a light, right? So most of the time it can be seen as like a green color, right? Which made other substances to give off light, right? So now here this discharge tube made by glass, when cathode radiation hit into this glass, we can observe like a green glow, right? Green color light, green glow, right? The radiation, continue. The radiation emitted from the cathode was the radiation emitted from the cathode was given the name, the radiation emitted from the cathode was given the name as cathode rays. Name as cathode rays. As cathode rays. Right. Then who are the scientists discovered by cathode rays? William Crookes. William Crookes. Right. Then after discovering this cathode ray by William Crookes, scientists start to study about this cathode rays. Right. Then write down next property. Next topic. Sorry. Properties of cathode rays. Properties of cathode rays. Properties of cathode rays. Right, first one, this is a glass tube, right? The glass tube and metal plate and high voltages, all of this one. High voltages, negatively charged, positively charged, vacuum pump, and this one is a cathode. Negatively charged plate is a cathode, and this is anode, positively charged, right? So then what they did, they place this kind of like known as a paddle wheel. This is known as a paddle wheel, right? This paddle wheel contain this kind of blades, right? Like a fan, right? Like a fan, right? So this is known as a paddle wheel, right? Place a paddle wheel. Paddle wheel. This is just a wheel, right? Paddle wheel is placed on the path of the cathode rays. Then cathode ray produce, this goes to here. Then they observe that the blades of the paddle wheel is rotated, right? That means this paddle wheel rotates. Paddle wheel rotate like this. Right? The paddle wheel rotate. Then what is the conclusion? To rotate this paddle wheel, the cathode rays should create a force on this paddle wheel. You understand? This paddle wheel rotate like this. Paddle wheel rotate, right? To rotate this paddle wheel, the cathode ray particles should create a force on the blade of this paddle wheel, right? To create a force, this cathode ray particle should have mass and velocity, right? To create a force, the particle should have mass and velocity, right? Particles having mass and velocity have momentum. What is the equation? Mass into velocity and kinetic energy. Half mv square. These are the two equations of momentum and kinetic energy. Momentum, mass into velocity. Kinetic energy, half mv square, right? Therefore, any particle having mass and velocity should have momentum and kinetic energy, right? So this blade of this paddle wheel rotate, then the cathode ray should create a force To create a force, it should have mass and velocity. Then what's the final conclusion? Cathode rays have momentum and kinetic energy. That's the first property of cathode ray, right? Okay, write down first one. Write down first one. On placing a light paddle wheel, on placing a light paddle wheel, on placing a light paddle wheel in the path of the cathode rays, on placing a light paddle wheel in the path of the cathode rays, on placing a light paddle wheel in the path of the cathode rays, the blades of the paddle wheel rotate. 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 Right. Draw this diagram. Draw this diagram. If you finish, please raise hand. Right. Then write down the note. Write down the note. To rotate the paddle wheel, to rotate the paddle wheel, to rotate the paddle wheel, cathode rays should create a force to rotate the paddle wheel. Cathode rays should create a force. Cathode rays should create a force on the blade of the paddle wheel. To rotate the paddle wheel, cathode rays should create a force on the blade of the paddle wheel. Should create a force on the blade of the paddle wheel. Paddle wheel. To create a force, to create a force, to create a force, to create a force, cathode ray particles should have, cathode ray particles should have, cathode ray particles should have mass and velocity. Cathode ray particles should have mass and velocity. Therefore, scientists concluded that, therefore, scientists concluded that cathode rays have momentum and kinetic energy. Therefore, scientists concluded that momentum and kinetic energy. Momentum and kinetic energy. Right, it's the first one. Then second one, in the path of this cathode ray, magnetic field. What do you mean by magnetic field? This is a setup. Negative, positive, anode, cathode, negative, positive, then electric field. That means the negatively charged and positively charged metal plate. This kind of negatively charged and positive charged metal plates are placed. Then what happens? This cathode ray particle deflect towards positively charged plate like this. Then the conclusion is cathode ray particles have negative charge, right? Because this is positive metal plate, negative metal plate. Then cathode ray particle deflection means the path is changed like this. It is known as a deflection, right? So deflection, they deflect positive metal plate, right? Then what is the conclusion? The cathode ray particle should have negative charge. It's the second property, right? Write down second one, second property. Second one, when an electric field is applied, when an electric field is applied, when an electric field is applied in the path of cathode rays, in the path of cathode rays, in the path of cathode rays, they are deflect towards the positively charged plate. They are deflect towards the positively charged plate. They are deflect towards the positively charged plate. When an electric field is applied in the path of cathode rays, they are deflected towards the positively charged plate. Right, draw. Deflected towards positively charged plate. Therefore, they have negative charge. Cathode ray particles have negative charge. And here you have to the vacuum pump. I miss it. Vacuum pump. If you finish, please raise hand. Right, then write down. Write down. Due to the deflection towards positively charged plate, due to the deflection towards the positively charged plate, due to the deflection towards the positively charged plate, scientists concluded that scientists concluded that scientists concluded that cathode rays are composed of negatively charged particles. Cathode rays are composed of negatively charged particles. Cathode rays are composed of negatively charged particles. Negatively charged particles. Right. Then next, third one. Third experiment. Right. So here, this is a magnetic field in north and south. Right. It's a magnetic field. So when N and north pole are present, the magnetic field is present towards N to S. That is why the arrows are like this, right? Magnetic field towards N to S. When this kind of magnetic field is placed in the path of cathode rays, what happens? The cathode ray deflect like this, right? We known as uh, cathode ray deflect perpendicular direction to the magnetic field, right? This is a magnetic field. Think this magnetic field. Then cathode ray coming here, they deflect like this, right? Perpendicular direction, like this magnetic field, and cathode rays are considered, they are perpendicular to the magnetic field, right? So then what is conclusion? Conclusion, cathode ray particles don't have magnetic property, right? So similar as here. So now think some particle have S magnetic property, it deflect towards N. If some particle has N magnetic property, it deflect towards S. But here cathode ray does not deflect N or S. Therefore, the final conclusion, the cathode ray particles don't have magnetic property. It's the final conclusion. Okay, write down third one. Third one. Third one. Cathode ray pass. Cathode ray pass through a magnetic field. Cathode rays. Cathode rays was passed through a magnetic field. Through a magnetic field. Magnetic field. It was observed that they deflect perpendicular direction to the magnetic field. They deflect perpendicular direction to the magnetic field. Perpendicular direction to the magnetic field. Right. Draw the setup. Draw the setup. Draw the setup. Draw the setup. Right, then write down cathode radiation. Cathode radiation did not attract towards cathode radiation did not attract towards towards NOS magnet. NOS magnet. Cathode radiation did not attract towards NOS magnet. Therefore, it was concluded that cathode radiation does not it was concluded that cathode radiation does not possess magnetic property. Cathode radiation does not possess magnetic property. Magnetic property. Magnetic property. Right. Then write down another subtopic. Movement of particle through a magnetic field. Movement of particle through a magnetic field. Movement of particle through a magnetic field. Right. So when a particle move through a magnetic field, the first thing is think some particle has N magnetic property. What happen? It attract towards S magnetic pole. Magnetic pole. Right? It attract towards S. If some particle has S magnetic property, what happen? It attract towards N. That's the first thing, right? If particle does not attract NOS, then what is the conclusion? Similar here, they don't have magnetic property, right? Then next one, when charge particle, right? When some charge particle pass through a magnetic field, what happen? It will deflect, right? It will deflect. The direction of deflection, right? The direction of deflection can be determined by using Fleming left-hand rule. I think it is in the O-level syllabus. You have to consider the left hand, right? So here, this is a magnetic field, this one, right? This is magnetic field and this one current. So one current and this is force, right? Magnetic field, current, force, right? Current. So I, what is I? Current. What is the direction of current? So the direction of current is the direction of moving positive particle. That means if positive particle move towards this side, current same side. If negative charge particle move other side, if negative charge particle move this side, then current other side, right? So this is the direction of current. Direction of current. The direction of the particle, the positive charge particle moving direction, right? So then now Fleming left hand rule. This is the left hand. Left hand, right? So here this represent magnetic field. Direction of magnetic field and this represent direction of current, and this represent the direction of force, right? So what is the direction of magnetic field? So the direction of magnetic field always from N to S, right? Magnetic field direction from N to S, right? So then think like this, I will draw here. There is N magnetic field and there is a S magnetic field. Then the direction of magnetic field N to S. Then think a positive charge particle. Positive charge particle pass through this magnetic field, right? Therefore, current this side, left to right, current this side, positive charge particle move this side, magnetic field this side, then force should be upside. Therefore, this particle move like this, upside. So then think negative charge particle pass, then what happened? When negative charge particle pass this direction, current, right? Therefore, like direction, they are force downside. Therefore, this negative charge particle deflect downside. Think uncharged particle, nothing happened, right? Particle, this is uncharged particle, no charge. No charge, then nothing happened, right? That is the next part, next point of the movement of magnetic field. And next one, third point, when charge particle, when some charge particle, positive or negative charge particle pass through a magnetic field, it will deflect, right? The magnitude of the deflection, magnitude of the deflection. What is the magnitude of the deflection? That means think a particle deflect like this, and I will consider as a capital B, and think another capital A particle like this, right? So then by comparing the deflection of A and B, we can say the deflection of B is higher than A, right? That means we can complete the circle of this path and complete the circle of this path. Then the radius of this path is lower than this one. Radius of path B, this one, particle B, like this. Then when complete the circle, this has lower radius, this has higher radius. Therefore, the deflection of capital B is higher than A, right? So this magnitude of the deflection depends on the two factors. What are the two factors? Mass and charge, E. Magnitude of the deflection depends on mass and charge. Mass should be decreased, right? Mass should be decreased and charge should be increased, right? That means with increasing the charge and with decreasing the mass, what happened? The particle deflect more. With increasing the charge, with decreasing the mass, the particle deflect more, right? When charge increase and mass decrease, what happened to this ratio? Charge to mass ratio. What happened to this charge to mass ratio? This should increase according to maths. When charge increase and mass decrease, what happened? The charge to mass ratio should be increased, right? Therefore, we can conclude that the charge to mass ratio of capital B is higher than capital A. Charge to mass ratio of capital B particle is higher than capital A because capital B particle deflect more than capital A, right? Therefore, what is the theory? The magnitude of the deflection increases with increasing charge to mass ratio. Therefore, if some particle deflect more, it has higher charge to mass ratio, right? So these are the theory points of movement of particle in magnetic field, right? Okay, write down first point. Write down first point. Particle having particle having N magnetic property, particle having capital N magnetic property, deflect towards S magnet, deflect towards S magnet, while a particle having S magnetic property, a particle having S magnetic property, a particle having S magnetic property, deflect towards N magnet, deflect towards capital N magnet, deflect towards N magnet, right? Then write down second one, when uncharged particle travel through a magnetic field, when uncharged particle travel through a magnetic field, when uncharged particle travel through a magnetic field, its path does not change. When uncharged particle travel through a magnetic field, its path does not change. Its path does not change. Does not change. Does not change. Its path doesn't change. But when charge particle when a charge particle travel through a magnetic field, when a charge particle travel through a magnetic field, when a charge particle travel through a magnetic field, it will deflect. It will deflect. Charge particle travel through a magnetic field, it will deflect. It will deflect. It will deflect. The direction of deflection, it will deflect. The direction of deflection can be determined. The direction of deflection can be determined by using the direction of deflection can be determined by using Fleming left hand rule. Fleming left hand rule. Fleming left hand rule. Fleming left hand rule. So draw this setup and draw this one. After that, draw this one. You have to draw these three setup. This setup, this one, and finally this one. Right, draw. After drawing, raise hand. Don't draw the last one. Under the third one, we have to write down a note. Then write down third one. Magnitude of the deflection. Magnitude of the deflection. Magnitude of third property. Magnitude of the deflection increases. Magnitude of the deflection increases with increasing charge. With increasing charge. Magnitude of the deflection increases with increasing charge. Within bracket write down simple E. Simple E. And with decreasing the mass. With decreasing the mass. Within bracket write down simple M. Simple M. Simple M. Therefore, the magnitude of the deflection increases. Therefore, the magnitude of the deflection increases. Therefore, the magnitude of the deflection increases with increasing. Therefore, the magnitude of the deflection increases with increasing charge divided by mass ratio. With increasing charge divided by mass ratio. Charge divided by mass ratio. Right? Then draw these two pathways A and B. These two as example A and B. A particle move like this, deflect. B particle move like this, deflect. A and B particle movement. Then write down deflection of particle B is higher than particle A. Deflection of particle B is higher than particle A. Deflection of particle B is higher than particle A. Particle A. Therefore, it can be concluded that. Therefore, it can be concluded that. Therefore, it can be concluded that charge to mass ratio. Therefore, it can be concluded that charge to mass ratio of capital B, charge to mass ratio of capital B particle is higher than capital A particle. Charge to mass ratio of capital B particle is higher than capital A particle. Charge to mass ratio of capital B particle is higher than capital A particle. Right, so using a video, I will show these properties of the cathode ray experiment, right? Properties of the cathode ray experiment. Right, here, so you can observe, this is a cathode ray tube, right? And here this is a vacuum pump, and negatively charged terminal, it is a cathode, and positively charged terminal, it is an anode. And there is a high voltage source. So the pressure of this tube decreases about 0.001 millimeter Hg is the unit of pressure. And the voltage increases to 10 kilowatt up to 20 kilowatt, right? So then you can observe the production of this cathode ray like this, right? The cathode ray is produced like this. Right? And it is not given still, the different one. Another property. Then here this is a paddle wheel, right? There is a paddle wheel. You can observe this paddle wheel is rotate, right? The paddle wheel is rotated like this. Then the conclusion, cathode ray have momentum and kinetic energy. And when this kind of electric field is applied, it deflects towards a positive electric field like this, positive electric field. And when magnetic field is applied, it is deflect like this, right? This magnetic field present inside, right? Magnetic field not top. This magnetic field is not present in the top of the discharge tube, right? It is behind the discharge tube, right? It is behind the discharge tube. It deflect like this. Right. So those are the properties of cathode rays, and we have another property to discuss. And after all the properties, I will teach you how using these properties and this experiment, how scientists concluded the occurrence of electron in matter, right? Next week. And next week, before the next class, I will send you the note, right? So go through the note and study well. If you have any doubt, you can send a message and ask me. So we can meet from the next class, right? So therefore, good night for all.